Okay, so hello everybody. Today we're going to be looking at... Music's a bit loud, okay, let me turn that down. Today we're going to be looking at a CAN add-on board for the Glasgow. I thought I'd give you a quick show around of what CAN is, what Glasgow is. For those that don't know, I'm not sure who's with us today, but lots of you, I'm aware, are sort of familiar with these things. So if we have a look here, we've got a Glasgow board, and it has these two sort of main interfaces, and the idea is that we're going to create an add-on board which will plug onto the top there. We are aiming for CAN, which is typically used in automotive, and it's kind of a semi-pseudo differential interface, is that right? And yeah, the idea is that we go on top of here and we can then plug a car in or whatever else we might be working with. There are sort of industrial sensors, that kind of stuff. So I've got some things to show. So I've got this other board here which I designed previously, which is a dual CAN interface to USB. And if people are interested, we can have a look at what CAN is sort of at the electrical level. If people aren't interested or already know, then we can gloss over that, that's no problem. So yeah, what I have here is a list of, no, not on this one, a list of requirements that we're going to try and work towards. Fundamentally, we'd like to be able to use a DE9 to connect to OBD2 connector, and this is something which you can commonly buy sort of just everywhere really. I think SparkFun have got some, and I'm sure other places have as well. And ideally we get two channels on this. So we'd have one channel, I think, coming out to DE9, and that would probably fit quite nicely just here. So we'd have a nice connector on the end, right angle connector, so it's not sort of vertically or whatever. But then for the other channel, I'm not quite sure what to do about it, and thinking I actually quite like the idea of some terminals so that you can just stuff some wires in. So I'm thinking spring-loaded terminals so that you can push the button, feed the wire in, let go, and it'll be nice and securely attached. For reference, these are screw terminals, and obviously you need a screwdriver and things, so little less idea. But yeah, so two interfaces. They won't be isolated, I don't think, on this, so planning on doing that in a future revision. But it will be CAN FD compliant, or it will support it. That's something which I think significantly will be in the gateware. I believe the transceiver I've picked out will be able to deal with that, no problem. What else to say? We've got software configurable termination. So at the moment on a board like this, I'm not sure if you can actually see in there, but there are these pads which you can make a solder bridge over, and that will apply the termination, and then you can just wipe that bridge away and the termination's removed. So that's quite a permanent option. For something like Glasgow, where you're dealing with different things on almost a day-by-day basis, I figure even a switch is probably not the right thing, given that everything Glasgow is driven through the command line application. So let's use software controllable termination. There is a question whether we should go for 60 ohms or 120 ohms. Typically in a CAN bus, you would have termination at either end of the bus, and you'd have 120 ohms on either end, which kind of comes to equivalent of about 60 ohms total. For small networks, I don't think I've ever had a problem just using 120 ohm termination and sort of not worrying about it. If anyone else has got different opinions, then please feel free to say. So I think I'm going to go for software configurable 120 ohm termination. There will be ESD protection. And yeah, this is the pinout I think we're going to go for on the DE9 to OBD2. I'm not sure there's much else to say on that front. I see some chat about hot chocolate. I think I've got hot chocolate. I've remembered my water today, so I'll try and drink it. I got quite thirsty in the last stream. Oh, thank you, Rachel. That'd be good. Okay, so in terms of the connector or the terminal block I was thinking of using, it's one of these, which is a TE connectivity something something something. The idea being that you push down on the plunger with a finger, it opens up this gate, and when you then release your finger, that gate closes on the wire and clamps it in place, which gives a really nice solid contact. And actually in high vibration environments and sort of industrial type settings, they tend to actively prefer sprung-loaded sort of caged clamps like this over screws, because they can't really come loose. You know, it is a spring, it is what it is. Whereas a screw can vibrate loose and wire falls out, whatever. Obliterous, yeah, 120 ohms at each end, which gives you an equivalent of 60 ohm total. So, you know, on a fully compliant bus, I think you'd see effectively a 60 ohm termination. Okay, I've forgotten about 100 ohm low speed. If everyone's okay, I think we're going to go for 120 ohm termination on board, and just go from there. If it works out to be wrong, then we can figure something else out. Hey, welcome. No worries, you're allowed to lurk. I'm fully okay with that. Chat or chip in or whatever, whenever you like, no problems. So as probably everybody is aware, this is Glasgow, primarily spearheaded by White Quark, and she's done a really amazing job as far as I'm concerned. This is the schematic which we'll be referring to obviously during the development of this add-on. Yeah, if you don't mind, Rachel, just a link or something to an image would be cool. So the Glasgow, these headers, these black connectors here, 1, 2, are actually these connectors here, so J3, and they share the same pinout. They're just sort of rotated 180 degrees from each other. So what we have is a supply voltage which can be configurable, and I think in this situation we're probably going to require 5 volts, and then we've got 8 digital bits that we can do almost anything with, which should be plenty. I mentioned this to a couple of people, but this is going to be my first proper KiCad exploration, so go gentle on me, but please feel free to help and shout at me if I'm doing silly things. I've got some ideas on how I think this is going to look from a schematic point of view as well as the physical point of view, so yeah, do shout. First things first, we need to find a connector, and I think you click one of these buttons up here. Sorry if it's going to be painful for everybody. By, what is it, 10? Is that going to bring us odd even? 1, 2, yep. A connector in here? We get to see it? Oh, there we go, I see, okay. Can I place that? No. Cool. This one? No. Place a symbol, that looks good. Right, so 2 by 10, odd even, one of them, 2 of them. I think there's a duplicate C, so if I hover over, and there we go. I'm referring to the schematic on my other screen, so if you want to play along, it's in the GitHub repository. I'll paste a quick link to that so that people can see. There we go. Right, so we're going to need some ground, which I suspect will be something like that. Our 0 volts. Not sure how other people feel about this, but I always like using 0 volts instead of GND for this kind of thing, because, oh, look at that, Rachel. Perfect. And then how do we draw a wire? Is that going to be a W? That'll do. Wire from there to there. Not pin 2, actually. Delete wire, just delete. There we go. Looks good. 0 volts is the way forward. Ground means something different. So I've been previously working with sort of industrial control systems, that kind of stuff, and all sorts of other industries as well, but you've got to be quite careful about what ground is and what it is not. Right, so here we've got How am I doing this? There we go. Can I copy that? Do I have to select it first? Nope. How do I copy that wire? Anybody? No, never mind. Oh. So if I press W, drag it out, and click, and then it's anchored it there. So if I now press escape, the whole thing goes away. Oh, double clicking. Gotcha, thank you. Right, so there's a little cross. Is that going to be a no connection flag? Perfect. Another one there. So these pins up here, 1 and 2, are for the vSense and the VIO, as in supply power and sense power. So we can confirm that on the back of the Glasgow itself. It's got a nice silk screen, and we've got the V supply is on the same side as the ground, and the vSense is on pin 1. Right, this is going to take a little bit of getting used to. Apologies. So there we go. We don't need to sense, we just need to supply power here. And I'm pleased to see people are happy with the 0 volts instead of ground. Yeah, that's good. So power. We're going to require this to be a 5 volt supply, I think, because of how CAN works and because of so there are options which allow us to use a 5 volt supply, which will then drive the bus, and a second supply to do the I/O. But given that Glasgow can only provide 1 supply per channel, and also Glasgow can deal with 5 volts I/O, let's just go for 5 volt. All right, out of these 8 bits, we've got to assign some signal, some net names. So let's have a quick look at what's it, TCAN, this one. So I think I've used this one in the past. It's what's on the board I showed you at the beginning, and I think I'm going to use it again here. Seems to do well. Supports CAN FD up to 5 megabits, so that's nice. There are 2 variants for this. There is one which has a separate VIO, like I mentioned earlier, and one which just uses VCC for everything. So when we're interfacing with this, we are on the external side, on the bus side, we have CAN high, CAN low. And then on the internal side, we have transmit data, a silent signal, and a receive data. And the silent signal can be used to sort of enforce a hardware-based silence, as in you may not assert yourself on the bus, basically. So I think if we go for transmit, receive, and silent on here, let's see if we can get a net name, global label, net label, that'll do. So CAN1 TXD, is that going to work? Do, needs to be a bit longer, that's fine. CAN1 RXD. And as a 4th one, it's not on the parts data sheet because it's separate, but there's the termination, sorry. So if we do CAN1 term, I think that will do us nicely. The other 4 signals, I'm not quite sure what to do now. I would quite like to have LEDs, I think, as in a send-receive type LED. It gives you some indication that something is going on the bus. So let's do that, I think. So CAN1 TX LED, CAN1 RX LED. Oops. There we go. So those last 2, I think maybe let's just get rid of them for now and put a little cross on there. And move this all over there. So that's 1 port, that's CAN1. Let's put that on connector A. So when I'm drawing schematics, I quite like things to make logical sense with respect to the hardware as well. So this is port A up top, and this is port B. Pin 1 is in this corner for A, and pin 1 is in this corner for B. So what I'm going to do is, if I can, I'm going to rotate that. Rotate just R, like this. Oh, I pointed the wrong corner, apologies, the internal corner. That'll be the A, and let's just put a little bit of text in there to say port A. And then we can probably, to be honest, duplicate that. So if we copy one of them, is that going to work? Duplicate? No. Oh, C for duplicate, whoops. So I copy. How do you select without moving things? I want to select all of this, then copy it. Oh, I can do Control V, Control C, Control V, sorry. Thank you for the link, Rachel. No worries. You kind of don't in 5.x. Is that like regarding the select stuff that I was asking about? Oh. So we've got this picture from Rachel, thank you. This is what? Sorry. We've got ground, D plus, D minus, or can high, can low. Which, does that relate nicely to what we have here? Let no move. Oh, that's okay. So on the pinout I've got here, it looks like we've got, I think it's different, I would say. Let's put that on hold. If anyone's willing to go look into it, that'd be very kind. But we can come back to that later when we're ready. I'll just hang on to Rachel's picture. Oh, apologies, not showing my screen. Right. So these ones need to change, and we can do that with E for edit and to. How does that sit? Not super happy about where those labels are. I'd like them to all be aligned on the other end of the text, but that's probably asking a bit too much, isn't it? Wait, no, that's different. Never mind. Is there no real thing regarding the just selecting stuff in KiCad? It seems to be something you can't do. Like something fixed in 6. Is that nightly maybe? I'll find that later. I downloaded the latest Windows release earlier today, so hopefully we're not too out of date. Yeah, cool. Okay. All right, Cam 1, Cam 2. I think that's probably pretty much everything from this point of view. Put that connector or that power port a bit more in a sensible place. Delete these chaps. Not ideal, but there we go. D. Okay. Ah, nice. Okay, so that's move with nets attached. So I could move this chappy. Ah, nice. Cool. Okay, thank you. All right, that goes over there. Grab, cool. Right, I quite like hierarchical designs. This is something which I tend to use when we're working with this kind of thing, because both of the channels are going to be identical. There's no real point in drawing it twice or taking up sort of page space, so might need to figure out how to do that. Do we have to draw a hierarchical block? Create a hierarchical sheet like that. Let's call this can X. Name can X. Just like that, and then we can probably give it entry points. Let's call this plus 5 volts. Capital V, little v. Give another one, which is going to be 0 volts. Oops, that's right. Let's give, what have we got? Transmit, receive, silent. TXD, RXD, and silent. And then we've got term. Oh. Okay. So I want to do this inside the sheet, as in I want to save this and open the can sheet and place a global label, do you think? Hierarchical pin importing from the corresponding sheet. Hierarchical pin. Oh dear. Okay. No, not that one, sorry. Place a hierarchical pin imported from the corresponding hierarchical label. That won't let me do anything. But if I try this one, which is a hierarchical pin in sheet, that won't let me do anything either. Place a hierarchical label, TXD for example, like that. Save and then go up a level. So I need to delete these. Oops. And then I can probably do the, yeah, there we go, yeah. Okay, nice. So let's go and put all the pins into here. Forgotten which one it was now. This one. So we've got RXD, got silent, we've got TXLED and RX LED, and we've got 0 volts and plus 5 volts. We've done that, capital V. Ooh, controversial. Okay, that looks good. So if we then come here and we can place the pins, so we got transmit, receive, silent, termination, LED, 0 volts goes down there, and plus volts goes there. Does that look okay? How do I resize this? Drag. No. Resize, I have to do it like that, okay. Ooh. So this is going to be sheet name cam1, I think. And then if we copy it, can't copy. Can I place another sheet though? Another create a hierarchical sheet. Oops. I don't think that's what I want to do. 5 volts and 0 volts are global nets, being those symbols as they are. So what we're saying is that this is connected to this. Is that correct? That is connected to that. The only way I can make that not happen. I suppose what we actually really need is a value here of. Can't change that. Yeah, so I guess what I really want is a new one with a different name, but I'm probably going to have to create it, aren't I? Alternatively, I could just put a label on the net, I guess. That's probably cheating, isn't it? This is can 1 plus 5 volts. That's a good point, well done. And that's actually 0 volts is 0 volts everywhere, so let's just do this one. Move that, rotate it appropriately. Put a wire on there. No. Oh, I see. There we go. Cool. All the grounds are connected. Yeah, we're happy to do that, I think. Or at least I'm happy to do that. Let's copy this to here. I like the way that the text is always on the left of the object. That's good. Can 2. Oops. Can 2 5 volts. Okay. Now then, how do we get another one of these? Enter sheet, import pins, delete. Yeah, the isolation will, but that will be taken care of within this sheet, I think, because all of these 0 volts here are all connected on the Glasgow itself. So within this sheet, we will then create an isolated 5 volt supply or whatever voltage we need, as well as a 0 volt or ground or whatever you want to call it. What happens if I do this and I use a file name that already exists? Can2. Link can2 to this file, yes. And now I want to import. Yeah, there we go. So transmit. Bit of a shame because got to lay the pins out again, but never mind. We got kind of space like that, and that. That. I think it's 0 volts and then 5 volts. Resize. Looks okay, doesn't it? There you go. Okay. We have a wire. And we're going to copy the wire, but you can't copy the wire. So we need a label. Is it just L? Yeah, L. So L is going to be can 1 plus 5 volts. I'm going to rotate it like that. I copy the wire now. I can copy the name. Let's just copy that then. Oh, don't need that one. Copy that. Yeah. Draw a wire. Nice. Can't get used to this wire escape mode or whatever you want to call it. Okay. That's really annoying that you can't copy a wire. Never mind. Tell you what I might be able to do actually. Oh no, because you can't copy a group, can you? Anyway. This is TXD. This is RXD. Oh, you can copy a group. I might have to play with that once I've done with these names, and then we can make the second just by copying it. So make a selection. Oh, okay. Let's do that. So even though it's dragging it around, I do Control C and it aborts that, and then I do Control V. Look at that. Lovely. Call that can2. Thank you, Rachel. Very good. Do I have to name all of these? Okay. Are we done? Or at least with sheet 1 I think we might be done. Bring that there. This is then going to be port... oh, that's port A, that's port B, isn't it? And let's move that. Yeah, so they're sort of lined up a bit. Move that. That looks alright. Right. We don't have any mounting points on the Glasgow itself apart from these corners, but I'm not really sure that the add-on needs mounting because it is a development tool. It's not something which is going to be sort of constructed and built as a product. So I think what I'm going to do is just leave the board as just a board with connectors on the bottom. So that's actually something that I've just reminded myself that's quite different from my usual workflow with Altium. To place this schematic symbol, I would need to have picked out a part, and possibly part number typically, that goes with it. But I think, from my understanding at least, that comes much later in KiCad. So let's stick with it. Do we have any sheet properties? Oh, sorry, people saying things. So you can also move the port's name and designator. Oh, this bit here? No, not that bit there. Move. Oh, this chap over here. Ah, nice. Rotate. In space. Yeah, that's a long one, isn't it? Let's do that. That looks much better. And let's move that as well. Yeah, better. Good suggestion. That is going to be across one down to... That one's going to join it. Although it doesn't seem to want to sit flush. Never mind. Why don't they line up? You're on a different grid or something, maybe. DNF. Okay. I think let's probably just keep going with the schematic and come back to that, seeing as we don't really mind too much. You edit the label and check if it's being centered. So, okay. Right, so if we horizontal align left. Yeah, much better. Look at that. Oh, it's possibly upside down even. This one doesn't line up now. Left align that. Oh, over there, eh? Better. This is the kind of thing that really gets me because I'm a little bit precious with this stuff. There we go, that'll do. Port B goes sort of there-ish, port A goes there-ish. Right, okay. I think that's good. Probably worth moving on through into the CanX sheet. Port A is upside down. Port A is upside down. You see, this is really interesting because it's completely invisible where the alignment point is on here. So if I do right align, I see. Yeah, okay. That's going to whiz off the edge of the screen. There you go. Right. Hi, Yesden. Nice to see you. Thank you for joining. It's where my cursor snaps to. If I move it... Oh, yeah, okay. Right. These subtle things, eh? Okay, next sheet. My understanding is that these two should be identical, so if I draw in one, I should get stuff happening in the other. So let's just give that a quick go. So save that, look at Can2. Yes, great. Okay, so in that case, can I have a a sheet local power pin? Or do you think I need to stick with the net names? That would make me a little bit unhappy, but never mind. Need the net name, that's fine. Plus 5 volts. And if I do plus 5 volts as the net name, is that going to make things unhappy? Because at this point it is basically plus 5 volts. Let's do... so 0 volts is actually a global, I think, as well, isn't it? So I don't need to pass it through here. Why is it there 3 times? Multiple names on the same net. So my expectation, I guess, is that this 5 volt net name here will not apply outside this sheet. The sheet is local and separate from the export label. That's good. Okay. And then that will be named. I didn't need to double it. Oh, okay. Not sure I like that, but okay, that's brain hurty in terms of readability, I think. But I'll just leave it like this if it works. What I seem to have now is three of these in each place, which I don't quite understand. If I try this, can you give me... No. So, hang on there then. Why are there 3? That is weird. Okay, I'm going to delete 2 of each. Oh, and then we get a little box up, which is good. Not sure if everyone can see that. Don't like the way it's moving my mouse around. Another thing to get used to. Cool. Right, so this 0 volt power object is global, is that right? So I don't actually need the you can change the mouse thing. Oh, I have to do that. No, I won't play with settings on the stream. I'll do that some other time. Thank you though for the tip. Let's put that up there. Power preferences. Never mind, don't worry. I'll deal with it for the stream. It's worthwhile. Modern toolset accelerated has got a tick, so I think we're all good. Center and warp on screen. Center and warp cursor on zoom. No, I don't want that. Never mind, that's fine. I'll deal with it for the stream. So I can get rid of these, I think, because they're global. Is that correct? Practical. Power pin, okay, resize. Dook, dook, dook. Where was it? There it is. Okay. 0 volts is 0 volts. Right, so LEDs. I like LEDs, positive polarity, unless they have good reason to not be, and I don't think they probably do in this situation. Glasgow can drive current to the points and everything. So, do I just type in LED and see what pops up? Do I need to do red or anything like that? Lots of different color combinations. Series, no. I'm just going to do LED and label it as red and green. Do we have a preference for what is red and what is green in terms of transmit versus receive? Resistor small, I think Rachel told me to use. Small, there you go. Very nice. Oh, baby resistor. One amber. Yeah, good question. Red and green is actually come to my attention in the last year or two for colorblind people. So I'm very happy, very, very happy to not use red and green and to use green and something else, or green and blue, or red and blue, or whatever. So let's have a little vote. Who wants what? That's probably not going to go so well in the chat, but green, amber, bicolor LED. Oh, bicolor LED even. So I did, on this board, I did use an RGB LED, and it works fine actually. So, so why don't we go for, let's go for a bicolor LED, why not? And actually, why not just go for an RGB LED? Because they are common and they are small and they look good. And maybe we can use another one of the colours for... oh, interesting, that's not quite what I'd expected. Another one of the colours for something else, like maybe silent mode or something. So I was expecting a common anode, is that the ground or 0 volt facing one? Anode, there we go. Cathode. Do they have a common anode symbol there? Yeah, I think that'll do. Delete. Put that there. Okay, it's there. Oh no. Is that the resistor value? I think it probably is, isn't it? Let's just delete one of these and do one at a time. So we've got a ref des, which I think is probably what this one is. And then we've also got the resistor value, so horizontal center and vertical bottom. That does it, yeah. That's the value, this one. Okay, cool. Thank you. Let's put center, and let's go for nothing yet, because we need to figure out what LED we're using. Do you reckon the value is going to fit inside? I don't know. Let's get rid of them. You reckon it will? It'll fit. Okay, let's go for 1K for now. I like to aim for sort of 100 microamps or something for modern LEDs, because otherwise they're just so bright. So I am going to put, let's have a look at the data sheet for this part. Is that silent mode positive or negative polarity? So silent mode, active high. So I think we can put silent into red probably. That'd be nice, because then it's kind of safe or whatever. So that's the red one there. Let's move this into place. You're not going to bend on the knee? No. Okay. Transmit and receive. Someone said transmit was green, did they? Back through the chat. Norm is green for transmit. Okay, so let's go with that then. I'm going to move that into place. And we can steal it when we need it. Actually, can I just copy that and have it in 2 places at once? Know about that. What are we trusting Obliterus on? Okay, let's see if they have one of these CAN parts in the library. TCAN 1051. That's probably not the way to do this, is it? In KiCad speak. TCAN. We've got other. Yeah, we have actually got other parts by specific name. So we haven't got a shutdown pin, so we can probably copy one of these. No fault. Yeah. Okay, let's try and copy that. How do we do that? We've got the symbol editor here. T-can. I suppose another option could be see if any of these are suitable already. 1 meg. What do you reckon about that one? T-can. Can I grab that? Yes. Oh, the TX colour, yeah. No, don't be silly. 943. This is looking like it's about 140 per one. Pin numbers is a good point, yes, thank you. Why don't we pick an LED? Not sure if I should just reuse the ones from that board I was showing earlier, or if anyone's got a favourite RGB LED, or if we should go digging for a new one. Let's go digging for a new one. Indication. I hate these these boxes, they're horrible. Right, so this is a common cathode, I think is what that part number means. So common cathode. Okay. So in part, if we're going to be using the red, for example, to deal with the silent, then actually we need it to be common cathode, because that will give us the ability for silent to go high and then the red LED to come on. So I'd quite like to keep that if possible. Go for a size. Lens size, package size, please. 1.6 mil. That'll do. There's only 3 left. I know. Looks good. In fact, that's, I think, the one I've already been using. 34p for 2000. £1 for one. Transistor to invert's a good idea as well. Let's have a look then at what options we have for configuration. Common anode. Many more, yeah, look at that. And this is again with RGB, oh, the size, what's the size? Size 1.6-ish, and below is probably good, I reckon. Not too small, 1x1. 119, yeah, okay, sold, let's go with that then. Unit price, and quantity. 8p for one. Oh, I think I've seen someone use them before. That looks very familiar to what I think Greg was showing off for the, what's it called, the orange crab. Let's see then, does this have a thing? No. But it will have LED RGBA, I think, won't it? And then we've just got to confirm the pin numbering. Aha, okay. Can we individually change these pins, or is that sort of a duplicate the part and make our own? That's fine if it is. So let's grab this. This is a Cree. And we have got a Cree hole already in my datasheet library, and it's one of those. Oops. Got one of these in. So what we're looking at, actually I'm going to use this. No, I'm not going to use that because I'm going to use this. There we go. There we go. So we have 1, 2, 3, 4, with 4 being the anode. This one. That looks okay, doesn't it? So, right, blue and red are swapped. So let's duplicate this part and sort that out quickly. New experience for me, at least. RGB, no, LED, RGBC, I think it is. RGBA. Never remember these things. Save a copy, duplicate. Oh, you reckon? BGRA. Hey! Okay. Sorry, Rachel, didn't see. LED, BGRA. And A is not for alpha in this case. I have to be careful of that one. So the dies are still laid out RGB, but the pin numbering is different, and that looks like it matches up. So blue is 1, green is 2, red is 3. There you go. Very good. Thank you. Yes, I can do some balls with the other side of things. Cool. Okay. No. Can you move the whole part? Thank you. Oh no, what did we go for? We went for blue is receive. Blue is receive, so we want a resistor. We want a blue. Oh. There we go. Transmit was on green. How are the levels, everybody, by the way? Music's not too loud and overwhelming or anything like that. Good, cool, thank you. Can I, so you see how the knee's gone that way? Can I just change it without retracing my steps? So I press spacebar, I think, in Altium to do that, at least. I'm saying I think because at this point it's muscle memory and I'm doubting myself, but so this is going to be SAD. I think it's slash. Okay, I'll give that a go next time. Thank you. That wants to be the 5-volt supply. So I want to have a copy of that. Date it around, put a wire in there. Cool. Definitely slash and PCB. Cool. We can get to that. Grab. Look at that. Oh. Okay. LED done. Let's move on. So I'm not sure if anyone's picked out a CAN part that they know or like. But I think it's probably, because I've used it before, it's sort of low risk. We can have a quick look at costs if you like. Let me pop this. That's a long part number. Let me just pop that in here. Got text, there we go. Right, so CAN transceiver. So this is one that's already in KiCad. It's £1.40 per in one-off quantities. Let's have a look for the TUSB 1051 that I've been using. Oh dear, that's not TUSB, so brain in the wrong place. In stock 1. Unit price, so that's sort of 86p, so what is it? Yeah, it's about twice the price, isn't it? Let's go for it. I've used it, I know it's good for 5 meg, or at least the datasheet says it. I haven't actually used it that fast. Huge mood, yeah, definitely. I have some hesitation to mode external ports away from edges after difficulty finding them in visualizations of Yosis Alpha. That's a very good point. When I do them, I do try to keep them close to the edge, so maybe we should follow the rule. There we go. Right, so this comes to, and then we can name it nicely as well. TX LED. I know it's different, but there we go. I don't. Someone commented a while ago on how sort of more recently schematics have become just net lists, and there's no sort of indication on what you're supposed to be trying to do with the schematic. So I do try to steer away from just making a net list, but I think for LEDs like this it's probably okay, and it's not a particularly complex schematic, so let's just stick with it. Right. I think let's draw out one of these. Where's it gone here? One of these footprints, not footprints, but schematic symbols. Take some water, everybody. Don't forget to drink. Okay. Now, do we automatically have a library for this project, or do I need to make a new library for this project? Or should I add it to Rachel's library? What does that mean? That's a cache. Make a new one, so let's call it Glasgow can dot whatever it comes out as. And this is project specific. Yes. Oh dear, where have we gone? I'll do it here for now, and then we can look at making another one later, if that's okay, or pulling it across into yours later, if that's okay. New symbol name. What's this going to be? So this is a TCAN 1051. U is correct. Number of units 1. Symbol with alternate body style. De Morgan. Not a power symbol. Units are not interchangeable. They probably will be. I think we'll just have to go with all of that. Oh, look at that. Okay, we've got our part number and our FDES. I don't know, the field footprint field datasheet. Oh, I see, okay. Are these text fields which I should be editing? Footprint is going to be, I don't know, I'll just leave it as FPR for the moment. And datasheet, I'm not going to link to, I'm just going to delete it. Probably want it on. So the units are not interchangeable. Where's it gone? It's probably in a different place now, isn't it? Units are not interchangeable. Oh, I can't turn it on now. So units in this, because there's only one unit, there's not sort of a separate power and logic element or whatever you want to refer to them as. I don't think I care, but I'm very happy for you to tell me otherwise, so feel free to speak up. If I was doing power and logic interface, then yes, I probably would have ticked that box. Add pins to symbol. Text. Yeah, cool, okay. Alright, so we have a pin. Let's get the, so I'm going to be referencing this. We've got a few options on the package. What should we go for? I'm tempted to go for a small one, that'd be nice. Let's just see, there are some odd things here about what is supported. Oh, these are all the Q ones, which I think is automotive. Oh no, they're all Q ones. That's okay. Let's just go with it. So some of them include the level shifter, some of them don't. Some of them support flexible data rate, some of them don't. They all support silent mode. Are you on the DFN part? Let's go with bus fault protection of really high, flexible data rate, and no level shifter, I think. So that would be this one here. Oops. My screenshot tool is being slow. There we go. So we're going to go for this one, I think, if everyone's happy with that. I'll keep that to one side just so that we remember. HG and HG. Oh, I see. V, GV. Okay, so we have an HG part that we've selected, which is one of these. And this is probably a top view, knowing them. So don't lake your footprint from it. I'm just going to keep that over there. Sorry you can't see it, but and we'll edit it. There we go. So no pins to bend. The solder, it is probably more difficult, depending on whether the pads come up the side and things like that can make a pretty big difference. If we bear in mind that these will probably be hand soldered, at least for the first version, then we can make the pads longer so that you can actually get heat into them. There you go. So there is a little bit of height on there, which I think will help us a little bit. Not much. Tack and go. So yeah, I think let's stick with it. It'll be a nice small part, and it's always fun to design something a little bit smaller, isn't it? Anyway, back to this. So we've got pin name TXD, pin number 1. This is an input graphic style. Yeah. I think that's good. Let's just go with it. Make another one. The next is the ground. Can I put this on top? I don't think I can fix it on top, sorry. You just have to remember it. Pin name ground, pin number 2. Is there a sort of tabular view where I can enter these details? VCC pin 3. RxD pin 4. And we've got S pin 8. And we've got CAN H pin 7. CAN L pin 6. And then in this case we've got an NC on pin 5. There's a tabular view. Oh, this one. In table. Oh, nice, okay. Yeah, there you go. Plus, plus, plus. Nice. I will remember that for packages with more pins, I think, if that's alright. So transmit, receive, and silent go on this side. And then we've got ground, and VCC go top and bottom. Should we do that? No, I think I'm going to put them here and here. There's probably some rules and style guides for KiCad, so if I'm doing it all against them, then do tell me. I don't have to list the NC, I agree, but I prefer to. Yeah, I think I'm going to go with that, and I will put this just on the bottom, apart from those are backwards. Okay. I need to bring these closer. So the grid here is unknown to me. Grid 1.27. Grid here is 1.27. So we're on grid, that's good. Let's move them close and let's move that away one. Let's do that and that. We can, high and low can be like that, and then that goes there. Cool. The big blue and black lines running to the top and bottom and left to right, these ones are the origin. Yes, yeah, I was just coming back to that once I've got everything in place. So this will be the outline, I think. And put that sort of there-ish. Yeah, thank you. Put that there, and that is left aligned. Vertical line center is fine, I think. That's there, and that will be left aligned as well. Footprint, give me the footprint. I'm going to put there. There's another one on here, isn't there? Datasheet. Where did the datasheet go? an invisible text label. Oops, never mind. All right, save, done. So can we place that? T can, nearly did T USB again. Look at that, brilliant. No, copy one of them to there with a wire. Need one of these. No, there isn't one there. Need a 0 volt thingy. There. Yeah, I was actually going to look at that because these have got a yellow background, haven't they? So if I do fill with body background colour. There, nice. Oh, it comes through just like that. That's nice and a little bit scary at the same time. Okay. So if we... I'm always really nervous of things that just happen like that, because kind of a hard one to justify being nervous of, I guess, but if you are, for example, sort of months into the design or further down the line and you come back and you change something, you tweak something and you don't realise that it's going to have this knock-on effect, then it just makes me nervous. I think that's all. I can't really say much more than that. I don't know about these. I want to break them in half. Oops. Right, that's good. Now, because we're having a different connector on each side, we can't put the CAN H, CAN L and its connector on this sheet because of the hierarchical stuff. So we need to give it a label. I think that was the right one to do. So this is going to be CAN H and then CAN L. And then we need to bring them into here. So we need to do that one, I think it was. Yeah, CAN H, CAN L. Now I'm all out of sync with each other, but that's okay. But in the middle, we want to have termination, we want to have ESD protection, and I think that's probably good. SLED will go to that transistor we were talking about earlier to invert the signal, so that when the... Well, let's do it now, why not? I like to use FETs just because I'm that kind of a person, so let's go for a FET. Do you reckon it'll have a... kind of FET are we after, etc. NFET? No. MOS. NMOS. I've changed the LED to common, whatever that is, common anode, because they're more available, I think, by the looks of it. I think there were 3 common cathode available parts, and there are hundreds, or over 100 common anode. NMOS and pin order, oh, just like before, very good. So NMOS, and oh, look at that. Oh, lovely. What have we got here then? Oops. I want the LED lit when S is high. Yes, because S is an active high signal and it turns the transceiver into silent mode, which means it should not affect the bus in any way. Right. I guess we need to go and find ourselves a MOSFET then. Single. In stock 1. Active. It's gone. I was about to pick. I don't mind about the TXRX LEDs because they're going to be driven by the gateway, so we can just invert it there, that's no problem. Obliterous, yeah, I'm using a FET. Is that is that horrible of me? Alright. We go for something smallish as well, make it a bit of a challenge to produce. By hand, at least. So the you probably want to add the part info you find each part as you're going. Okay, so so I added it here. Oh, Blitrus, yeah. That'd be a big LED. Okay. Thank you, Rachel. 1051 HG Q1 is what we're going for there. And the manufacturer is going to be Texas Instruments. Is that something? Oh yeah, I can make it visible, so I can turn that one off and give it a more precise part number. Got the wrong colour, but never mind. I think I don't mind too much. This LED exactly, so I put a little note beside it, so this is going to be MPN and it's going to be that value there. And MFR, I think it was Cree, perhaps? Yeah, Cree, this one. So what did I put in the part number there? Oh, does it? Okay. Right, so the Cree data sheet has got, presumably, there we go. Oh, wow. That's a bit precise, isn't it? I don't think I care about any of this binning or how it's packaged. And that's an X. So we end up with the first bit, DXG, FKA, so I'm going to go with that. Oh, neat. Okay, thanks, Rachel. There's only one option from DigiKey, but I think... So what have we got? DXG. We've got... Oops. FKA, so A is a black body. So if I just put that, what do we get? Yeah, it's just the same. Okay, I'm going to stick with up to the FKA dash. And you want that in the part number, oh sorry, the value as well. And this is going to be a property. I'm not getting them from DigiKey, I'm just looking at DigiKey because it's a supplier, if that makes sense. I will probably order them elsewhere when the time comes. So I can get rid of that. That's a bad place to look through, oh dear. I've seen lots of people using LCSC. How come? They're just better. Oh, it's only got... Okay, so let's have a look then at this. Oops. Oh, what? Oh, okay, so they're not official Cree. That's fine. I'm happy with whatever at the moment. Since fair enough. So it's a alternative compatible part, I presume, rather than the actual Cree part. But if it's a compatible, then let's just stick with the Cree part number, because at least it has a data sheet. Yes. Anyway. That's true. RGB LED. We could go for something else. I actually feel like having picked a 1x1 mm. Where is it? Here it is. 1x1 mm is probably a silly idea, isn't it? Go for that kind of size. buy that. 34p. Thank you for the link. Oops. Goose. Yeah, 2.7 cents. That's nice. Okay. Is this going to have a thing in here? Is this going to be the correct kind of orientation in terms of common anode, common cathode? Common, whatever that is. Oh, thank you. So that's already in the not that one. Come back. In here. Oh. So I guess I'd use the same footprint. Sorry, I'd use the same schematic symbol, but with a different footprint behind it. So this is the part, Rachel, I think. We want, we want, I think that's the correct orientation. I'm really not good at seeing things on two different windows, there you go. So, especially when they're drawn funny. I think that's okay. We might need to change the color order. Let's do that quickly. Pin numbers, anywhere? There we go. I think this lists the pin colours. Not great. So this is interesting because I've rarely used DigiKey. No, sorry, I've rarely used LCSC for finding and sourcing parts. The Glasgows I produced, the pink LED or the blue LED. No, it was the pink. Came from LCSC, but I think everything else, because PCBWay took care of the procuring the parts, they just sort of dealt with it for me. So this is an RB plus RBAG. There you go. Neat. Thank you, Rachel. Right, so MFR and no MPN. To come to here, the manufacturer just put it down as that, and the part number put it down as that, and we can deal with the rest later. I think put that in there. There we go. Cool. Yeah, it's neat actually. I quite like the way they've got parts for all the combinations. Thank you, by the way, for figuring it out for me. I did confirm it, but it was good to have confirmation. Alright, so on Discord, Electronic Eel suggested a photo MOS for, here it is, sorry I've lost it, for the termination. And I think I'm happy to go with it. It looks good. It's got fairly low like on resistance, RDS on, whatever. It's probably not called that because of what it is. So we have Toshiba, and it's the TLP240A. Yeah. So it's one of these basically, and it lets you shine a light on the pair, and they then start conducting. Or at least I believe it's that way around. Off state, trigger LED current, on state current 500 milliamps, on state resistance 2 ohms. In terms of current, it's not sinking current so much as suppressing the reflections, I think, in terms of CAN termination. So typically you have 120 ohms on either end of the bus, which gives you a total of about 60 ohms. So the line drivers need to be able to dump current into the termination, obviously, but it's not about sinking current, it's about suppressing reflections more, I think. Aha, okay. So we have it. It's not going to be dealing with 12 volt shorts, but planning on putting ESD protection on there. So in terms of this part, if we had, so say CAN H on 24 volts and CAN L on, I was just reading the chat. Yeah, so if CAN H was on, get the book out. Not sure if you'll be able to see that, hopefully you will. The CAN H on 24 volts, by mistake, CAN L on 0 volts. Is that a bit washed out? Rachel's given the maths. Can you read that? I think probably not. Or maybe just about. But you'd end up with, effectively, a resistor which is 120 ohms, followed by this box that we're about to put in. So you'd have 2-ish ohms there. So you'd have V, I, R, and P. I always draw this out, PIV. 200 milliamps. So I think that's probably okay. Especially as this is rated for 500 milliamps max on current. So yeah, let's go with it. Let's do a resistor. What are we doing? Yeah, okay, so we're doing the CAN interface now. Coming out of here, we want the termination. We were looking for this part, which is one of them. Let's see if you've got one of them in stock. Nope. Okay, so we have to draw one up. I've got the data sheet for it here. And I'm going to try and, so I was saying earlier about how I like my schematics to tell a story or whatever. I'm going to try and draw something pretty similar to that in the schematic symbol. It's one of them, I think that's all good, same as before. But what I'm going to do, because I'm going to try and be a bit lazy, is I'm going to try and just steal another NFET, which already exists. Is it NMOS? Okay. So I'm just going to steal all of that, copy. Actually, there is a body diode drawn in the datasheet, so let's have a look at them quickly. That'll do, that's nice. Yeah. Oops. We can just delete those. Nope, not all of that. We want to delete this. Paste this in. And we want two of them. We want one of them to be the other way up though. Not sure if that's something we can just do, or if we're going to have to. There we go. That way up. I'm looking at the datasheet again on my other screen, so apologies there. There we go. Let's get rid of the circle as well, can we? Bit off grid. How do I get that circle? Is there sort of a press shift or press control to get line of grid? No. Okay, circle center. Cool. Put them there. Let's do that. That'll do. No, wrong one. Oh, it's gone all the way through. That's fine. Let's just do that. And then we have a pin, and this is going to be the. I think I'm going to call it out one or something. just for the moment at least. Can I flip them from here? I can't, but I can rotate them twice. Okay, so this is pin number what? It's going to be pin number 4, and this is going to be pin number 3. And I think, do I just leave this empty if I don't want a pin name? That looks like it'll deal with it okay. Move that, grab that. Yeah, look at this. Getting good at KiCad. Is that just a line? Polyline? Can I add a new segment to a polyline? How about that? You'd set it passive, okay. That's a good point. I didn't even think about that one. Thank you. New polyline, okay. And then okay. Does a polyline have a letter or a keyboard button I can press to get it to happen? Oops. Very cool, don't worry. Right, let's grab some of the shiny lights from an LED because I'm lazy. In fact, we've got an LED with it. That was a mistake, but worked out nicely. We'll probably even get away with doing a bit of that as well, can't we? Okay. Copy the pin. Can't copy the pin. Never mind. Put that here. This is going to be LED. Oh, I hate this so much. What are the bets? Anode is the positive side of an LED, which is what we're on, which is pin 1. So my frustration with anode cathode stuff is that it's not consistent. That's a really, really lame excuse, but I'm going to stick with it. Actually, I don't want to give it a name anyway because it's descriptive as a symbol, so that's fine. Can't copy the pin. And this is then going to be pin 2. Good. Now we need a box. Is that going to be a resize option there? Cathode is abbreviated K, yeah. So my issue with anode and cathode is it's about the chemistry, I think, isn't it? So, for example, batteries or cells have the opposite to an LED, I think, which is weird. And I can't resize this because... Oh, drag rectangle edge G. Okay, there we go. Polyline, put that there, that there, grab that, yeah, look at that, getting good. Background, there we go. Okay. Move that up here. No, other way around. There was a footprint one as well, which I think I'm going to try and put FPR in again, because otherwise we'll lose it. That sort of middle-ish. Put that there. I would like this to be, sorry, just catching up on the chat, I would quite like this to potentially be a product. So it makes sense to try and deal with things when they make sense like that. Right, let's have a look. If you change the U here, it should change the designator. Yeah, what do we want, Q? Or is everyone going to yell at me and say, no T? Maybe that. There we go. Right, so this will need a resistor to limit the current through that LED. Small. Good. We'll need a ground point or 0 volt point. We will need this to go then through resistor, which is going to be our termination resistor. So I'm going to put it on the top side, but I don't think it matters at all. T is transformer, is it? Okay. Interesting how different companies, different whatevers have different rules about ref des and all that stuff. But I'm easy. I like Q. Q's good. So in this case, that is the value. That is the ref des. That is the ref des, which is aligned wrong. That's probably aligned wrong as well. No, it's not. Okay, fine. That's also aligned wrong. That's interesting. Is it to do with the orientation, do you think? So this is going to be 120 ohms, which doesn't fit. Going to go outside. Opto, 4 letters on a ref des. That's very extravagant. Okay, what we have then is a 5 volt termination signal coming in and an LED which is able to take, let me get the data sheet, LED which is able to take up to forward current 30 milliamps, up to an amp pulsed, ouch. So let's aim for 20 milliamps or maybe even 15. This is where my my head falls in, so we've got, you reckon 10? Okay. With optos, I'm always nervous because you can't see them working. And if you don't give them enough, does the FET start to not conduct properly, etc. I don't have a good handle on that one. 15 for safety. Let's go for 15. So I equals 15 milliamps, B equals 5 volts, which means that R equals what? So our forward voltage drop is, these are the absolute maximum ratings. Here's the recommended operating. Forward current recommended 7.5, we were way over. Forward voltage 1.27. Oops. Oh no. So V equals 5 volts. VF equals 1.27. Therefore VR equals, I'm going to use a calculator, 3.73 volts. Let's put this somewhere before I lose it again. We're aiming for I equals, it was 7.5, yeah, 7.5 milliamps. Therefore, I did that again. Therefore, R equals what? Probably in the chat. 506 ohms. Now, this is another thing which I don't have in my head, which is the R20, whatever it is. I'm going to reference resistor values. There we go. The E24. So we are after 506 ohms. A value of 510 will do us nicely, I think. Cool, thank you, Rachel. I haven't actually done the sums. I don't not trust you, but I'm just going to do them for completeness, if you don't mind. Oh, I got 497 ohms. So 3.73 volts, V over IR, so divided by 7.5, it's 497 ohms. But I think we're close enough. Making it bigger is only going to go. Oh, Rink, not come across Rink before. Give that a quick go. Oh, it's a project. Oh, okay, I will definitely check that out after the stream. Thank you. Alright, let's move this into place. It's a bit wide. Wrap it round a bit. Don't need to keep it, but I like sort of self-documenting, whatever you want to call it. Right, so this is CAN H. We're going to drive it all the way along. We're not going to drive it all the way along to the end. Going to move that onto it. Nope. Go on, thank you. And this is then CAN low, which is going to come all the way to the same point. And now we want some ESD protection. So ESD wise, I'm probably going to get a clobbered ear from Esden for looking on DigiKey again, aren't I? ESD CAN, I think, will give us something. I think this might be the one I've used previously, actually. So let's do one off small cost first. He's only concerned about wallet, that's true. So we got 28p, say, for a single part, which will do both sides. It'll clamp it to 42 volts, which is quite a lot. What's the TCAN thingy rated to? Absolute maximum ratings. Oh, 58, that's alright. Oh, devices with are up to 70. I remember now we chose the one with, didn't we? In fact, here it is. So I think 70 volts and one of them is probably fine. That's 28p. So LCSC gives us what? ESD can. Oh. Not many. Oh, look. Same part number popping up. $6p, 4p, 4 cents even, sorry. So that is TPESD1 can, Tech Public. Very interesting. I need to use LCSC more, I think, don't I? Do you reckon that's going to do what we want? Oh, it does go sideways. No information. Next period even have got 7.2p. I'm gonna pop that in here quickly, see what it comes. No. Oh, there you go. The 28p versus. That's ridiculous. Okay. Yeah, the next period part looks good to me. Oops. Oh. That's a prefix, isn't it? That's okay. We can look through it. So, we want one of these. Do you reckon that's going to be a nice part of the shelf in here as well? What are we going to do? TVS. Device. Not quite. Oh, yeah, there we go. So we've got not that, no. Okay, so they're pointing the wrong way, but we can make another one, and I'm not sure that actually probably matters much. What does matter is the pin ordering with common on 3. So that's this, isn't it? Look at that. So I think using that for a part with a pin out like that is probably okay. Everyone agree? Because back to back versus face to face is probably the same, isn't it? More water, more water. Good. Thank you, Rachel. Copy that. So this is where if the isolation was on this board, we would have this section isolated. So the termination probably wouldn't be, but the ESD would be referenced to the isolated ground, and the right-hand side of the CAN transceiver would be related to the right-hand ground. This already gives us isolation, which is awesome, so we don't actually need to change that part of the design. We might even just get away with slightly modified layout and a new transceiver. Or we could be lazy and put sort of inline termination, or sorry, isolation here. But that's for later. Nope. Grab that. Grab that. Okay, how are we doing? We've got the termination done. We've got the transceiver done. We've got the 5 we've got the LEDs. We need to do the inversion for this chap. I think I got derailed at some point. So a little FET, which just turns that signal upside down, means that we can then take the... Let me just label these up, because that's going to bother me otherwise. TXT. And S. Can I break this line, or do I have to grab it like that? Mirror. Oh, I missed. Come on. No. X. Y. There we go. Cool. Thank you. Okay. Right, this LED hasn't got current resistors yet, so let's put a little to-do on those. That's fine, we can come back to that. Let's concentrate on the termination. No, not the termination, the inverting of this silent signal. Come on, thank you. Is this important enough to have an LED? Just thinking of the cost side that Esden put through just now. NFET. Probably not what I want actually, is it? So this is my go-to. This is my go-to. That's probably going to be the different website now, but I always, yeah, this is the one I always look up because it's not something that comes easy to me, unfortunately. These are all BJTs. These are, where is it? There we go. No. The MOSFET, there we go. It's not so much about how it's wired up, it's more about which polarity, I guess you would call it. So here we're trying to pull down, which means that the LED is on top of that. Let's move these into place quickly. Ooh. So this is trying to pull down on the LED. And when this is high, you want to pull down. So that means we want a low side switch. MOSFET as a switch, finally. Okay. There we go. Yeah, so it is an NFET. And there's our load, there's our gate, so that's fine. NFET, and this is, no, NMOS is it? NMOS, there we go. It's potentially going to have the pin ordering, so that's where we got to previously. P versus N, yeah, I always get confused. And they're different, BJT versus MOSFET as well, so it confuses me even more, and so I always look it up just to be sure. It is until you consider that BJT is opposite. Just like anode cathode, one of those things that just trips me up every time. We're having little, what's the word? Confessions of an electronics design engineer. There we go. No, it's easier to just pretend they don't exist, isn't it? Right, what are we doing? N channel. One channel. We want... That's true, yeah. But the arrow is different as well, isn't it, I think? I can't remember, never mind. It's all good. But this is not what we're after. We're after a single... Oh, here we go, sideways. No. These are big. Where are the milliamp? You sure, Rachel? Okay, fair enough. I'm not going to doubt you more than that. Why not, Esden? Oh, I think Electric Gill just said something. Let me just grab my Discord quickly and have a look, if you don't mind. I think it might be related. Okay, that's not so bad. We can probably ignore that one. This is true. Yeah, the voltage versus current controlled. That's the kind of thing I'm after. Just little one of them. Even a package. Sorry, it's far left. Okay. Oh, but it's not listed as a package. It's SOT 23. Yes, charge controlled, and something that people often don't realise is that particularly on big FETs, it can actually take quite a bit of current to get that gate charged and discharged. So if your gate resistor is too big, you can actually have a significant period where it's in sort of the semiconductor state, whatever it's called. Linear region, thank you. I'm very good at my words, especially this evening. Right, stuck on picking a FET. I'm just going to go back to DigiKey, I think. Because LCSC doesn't seem to have the options which will make my life a bit easier to pick a package. I'm pretty sure they say package. SOT 23 was somewhere. SOT 23 as a package, but then it's not in this list up here. Unless I'm going crazy. Yeah, never mind. Single FET. N channel. Oh. Active. Ding ding. Ooh, that's quite a lot, isn't it? Never mind. Oh, BGS Max, I think, go for 8 and above. You have to go really high sometimes on these. That's fine. Package, that's the next one. Series packaging. Package case. There we go, C70 would be good. SOT 23 would be good too. There we go, 23, 3. Cool. There we go. So, one of these, 17p, let's give it a quick sort, 9p, that'll do. Another Nexperia part. 270 milliamps, that's plenty for an LED. RDS on 2.8 ohms, no problem. I think that looks good. Go for one of them. Close up some of these. This is going to be another new part. There we go. So this is what we're after. And if we come back to EE Schema, I think Rachel's little discovery about the pin numbering ordering. Oh, that's not what I wanted. Sorry, it's on the other page. Oh, great. So here we go. Pin 1, gate. So we want gate source drain, GSD. GSD. How does that look? Does it look like what we want? Yes, that'll do nicely. Pulling down. Delete these. You can delete the name even. Put that there. Put one of them there. And put a resistor. No. Why do I keep pressing? N? What does N do? Not sure. Never mind. Move that out. Center, center. Center, bottom. Right, okay. 1K is fine, especially if we've got others. Let's first of all figure out what these LEDs want. This is an FM something. I remember. Yeah. That's not what I wanted. N changes the grid in PCB mode. Okay. I think it seemed to rotate things just now in schema, E schema. So if I press N on this resistor here, boom. I don't quite know why, because if I press N again, it doesn't do anything more. It just rotates it one step, and then I do lots of Control Zs. There we go. And it finally came back. I don't know. Never mind. Maybe it's a reset or something. Did I grab one of these? No. Resets the orientation. Yeah, I wonder if it resets things. Okay, here we go. We've got 3 LEDs in this package. Forward voltage of different values each. Yeah, so 8 milliamps, 5 milliamps, 3 milliamps. I think that's going to be massively bright. I usually aim for about 100 microamps on these LEDs. And if you want to get them the same brightness, you can do all kinds of extreme maths to get the luminous intensities and everything matched up. And looking at the graphs of the other thing, of course, is that human eyes aren't receptive to light in the same way across the spectrum. So you have to be quite careful if you want to do it. And probably by hand is good. Oh, 5K and 1K. Let's, if you don't mind, I'm going to do my figures and see where we come out to. Looks like 5:1 ratio. Okay. So, I reckon we've got the, so red. VF is, what was it? Red is 2. And we're aiming for I is 100 microamps, which gives us VR of 3 volts. 100 microamps over 3 volts. 30K. Is that right? Yeah, true. God, it's massive, isn't it? It's a huge difference. Oh, I see what you're saying. So what, 170 divided by 25 is 6.8? Yeah, okay. 170 divided by 55 is 3. So you reckon green needs even more suppressing? Right. Yeah, so I'm going to aim for about 30k on red. Let me just do this, otherwise I'll lose it. Green has got a forward voltage of 3. So you reckon green wants to be like 20 microamps? Is that what we're going to go for? I might go for 50. See what comes out. Oop. Uh, 2 divided by 50 microamps. Oops, that's milli. Is 40k. So these are quite large. And this is what always seems to trip people up, I think, is that they're surprisingly big. And oh, it's not monospaced. What? What? Blue. BF is 3.0 volts. I is 100 microamps again. It is, yeah, in terms of sensitive to green light. So 2 over 100 microamps is 20k. How do we feel about those values then? Can I make this monospaced? I can't, can I? You think 20 over 50? That's 100k. That's big. I'm happy, but it's big. We can probably consolidate, as you said, green and blue to say 25k, green to 100k. How do you feel about that? You still think green needs to be bigger? Is that what you're saying? Or are you happy with 25-ish K for red and blue? 25k, 100k, 25k. Yeah, nice. Let's go for it. Oh no, picked up the wrong thing. Can't quite fit those in happily, so I'm just going to spread them out a bit. Delete that, move that to there. I think that's good. Right, done the ESD protection, we've done the termination, we've done the transceiver. Haven't got any capacitors on there, so let's put one of them in quickly. Just 100 nano or something. C small again. That's good. Copy that. Oh, what have I done? Okay. No. Cool. Put that with you. Grab this one. they're recommended, are they? Cool. 4.7 U. No, get off. Duplicate that. So we reckon. Right, this is going to be center bottom. Move. And this is going to be center top. Delete. Copy. Move apart. Right, so 100 nano and 4.7 micro. That'll do. Nice. Thank you for that. Cool. All right. Good. Good. Yes. Private Kingdom. Okay, so now we've got a DE9, which we may have in stock. By stock, I of course mean in library. So DE9, DB9. There we go. Oh. All the decoupling caps. Right, so if we go back to my original plan, I hate male female, it's so stupid. I'm going to go with that being male, but let's check. No, I want to Y, there we go. So we are looking for the one with the pins, which is not, oh for goodness sake. That's called itself male. Oh, that has actually called itself female, okay. Right, I think we're good to go then with male. Rachel, this is where your photo from earlier comes back, and I think I've lost it because I closed it sometime. Where is it? GitHub, oh, Rink. Oh, I seem to be missing a whole bunch of the chat in my scroll back. That's weird. Alright, photos. Do you reckon it's this one? I think it probably is, yes. The joys of having a fairly clean browser. So, what we've got pictured here, oh I see, this is where the board would be, and these pins should be going into the board, is that right? And then on the close edge we've got 5, and on the far edge we've got 4. They're the back row, yeah. So that puts ground on pin, let's get rid of that, ground on pin this one, which I think is one over from where I got it. And then your can are paired up directly next to each other, whereas mine have got a gap. So let's have a look for a DB, of course, 92 OBD2 cable pin out. Obitronic SparkFun, I think, is a good reference, probably. Oh, can't you draw it? Oh, for goodness sake. Yeah. No, okay. Oops. I closed the SparkFun one by mistake. So what we reckon here is DB9. So we've got chassis ground, signal ground are 2 separate pins. Right, they're just completely different to that picture I've got. So let's ignore the picture I've got. I'm going to put this on my other screen. Signal ground is where yours is on. Yeah, pin 1. I think signal ground and chassis ground we should leave separate. I'm going to use signal ground. I need one of them. Where is it? Yeah. And then on the chassis ground, I'm going to label it, but I'm not going to wire it up. Oh dear, that's a bit long. Oh, that's a good point, Esden, thank you. The one wire stuff I was going to talk about. So the TCAN thingy, the transceiver we're using, I'm not convinced it will work with one wire CAN. I think that some differential transceivers will work in sort of a fallback or a single wire mode. But if we have a look here at the receive terminal, oh no, sorry, the transmit. Wait, can transmit data input, can receive data output. Right, this is what we want, the differential driver characteristics. So the differential output is ignored. Where is it? These are all outputs. Are these inputs here? So the output voltage for dominant versus recessive and the differential values. But then I want to know about the input values as well. Oh, receiver, sorry, and that's next page. So because of what CAN is, CAN trace. That's hilarious. Oh dear, CAN signal trace. Do you reckon that's going to give it to us? No, CAN bus. Oh, for goodness sake. There we go. This, right. Come on. I'll do. Actually, Wikipedia is probably not a bad idea, is it? I think that's where that comes from. Come on. Right, so what we end up with is the line's pretty close together for the recessive, and then dominant, it pushes CAN high up and CAN low down. So if we were to take the requested week, so Will C said, if you want help testing, let me know. I work on a number of different vehicles. An easy way to ground CAN low would be fun to have so you can talk to a single wire CAN networks. But it's a hack, but it works. So what he wants to do, or what they want to do, is pull CAN low permanently to 0 volts, leaving CAN high floating around. I guess if CAN high comes down to 0 as well, that's probably okay actually. Yeah, alright. Let's... no, Rachel, I think these idle at about 2.5 volts, and when you go dominant on the bus, you push CAN high up to nearly 5 and you pull CAN low down to about 0. Or at least that's how it's worked for me in the past. Yeah. So if CAN low is always 0, because of the termination, it's going to pull CAN high to it, right? But then because of the way the TCAN works, it actually produces this bias itself. So it's going to try and pull CAN high up as part of its biasing. So if it pulls hard enough to get over 120, no, where is it? Maybe these two, isn't it? Positive going in input threshold. Have we got any graphs to show us what's actually going on here? Yeah, so this is on the same y-axis here. So if blue is just 0 all the time, red is going to probably be close to, but it's going to be pulled up a bit by the biasing. And if it's over the threshold, then it's going to see it as a dominant state all the time. I think maybe let's put the option in. So okay, well, we're planning to have I've lost it now, but one of these. There we go. Oh no! I think we've lost internet. Let's do this quickly. Yeah, there we go. Are we back? Yes, welcome back. No, my internet connection went down. Thank you for sticking around. So, right, so we're planning on using one of these with the paddles to push the gates open. So, are we all back okay? I think Rachel seems to imply yes, but others are since saying no. So my thinking basically is that here we can just put a wire in from can low to 0 volts, and that can be our sort of really lazy way of facilitating this. If we then decide that actually yes, it is possible to do that with the T can 1051 or whatever it was, then I think it might be worth adding that as a jumper or something that you can plug in. So I think I'm okay to leave that if everyone else is alright with that too. Right, so carrying on here, we got oh, no worries, Obliterous, thank you for joining us. So can low is 5. This is interesting, because I think that again is different to Rachel's pin-up. Can low. Let's grab that picture back. Probably closed it again, haven't I? So that'll be 1, 2, 3, 4, 5, 6, 7. So 5 and 7, I think you've got there. Oh, hang on. I know it runs along the front. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4. So yeah, 3 and 4. Which is, I think, not compatible with this pinout, at least from SparkFun, where they've got 3 and 5. 4 being another interface. So, Rachel, is yours designed for use with one of these cables, do you know? With the OBD2 on the end? Or is yours more of a sort of in-house thing? So here we've got 2 is chassis, 1 is signal ground, 3 can high, and 5 can low. Sorry, just looking at another pin out here. So I think, okay, interesting. So these OBD2 cables are seemingly wrong. Peak can. Let's look at that. There we go. So we've got pin 1 not another set, but can low is on 2, can high is on 7. Low is on 2, so there's these 2 pins here. Not even Rachel's pin out. Bye, Blitterus, thank you very much for joining. Hope you have a good evening or whatever time it is with you. What to do about these pinouts? Honestly, I'm pretty tempted to go with an OBD2 cable pinout, because I suspect that might be what people are using, and we can always adapt to others like the Peak, which is different to Rachel's, which is different to the OBD2 cables, seemingly. If you do have others, don't forget we've also got the plungers to just feed in wires. So I think I'm going to do that, if that's okay. I'm going to put a note here just so that this is note intended OBD2 to DE9 cables, just so it's clear what we're doing. Oh, you can't align them. Check pin out. It's a whole thing, yeah. The pinout being the Peak pinout. Oh, yeah, okay. Sorry, I just read your previous message. Never mind. Let's go with this. We can always revise it if we need to. Check your pinout / cable. That'll do. Okay. I'm gonna just delete these, I think, because they kind of serve no purpose anymore. Ding, 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 ding. Oops. Nope. Okay. And now we need the can 2. Oops. Can L, can H. Move that here. Cool. No. Oh, thank you. Can 1 L. Can 2, can 2. And this one as well. Cool. Right, so for the last one, I think we need a 1x3. 1x3, is that going to be a generic? 1x30, I don't want 1x30, 1x3, 1x03. There we go. Screw terminal. Not a screw terminal, but that'll do. There you go. Generic connector. Y. What do people reckon about this then? On the board I was showing earlier, I've got ground, can low, can high. I've seen ground in the middle. I've seen whatever else. So I think I might stick with it and do ground on one end. Yeah, I think I agree. And pin 1 is ground as well, because that That makes a lot more sense to some people like me. Right. Cool. Can two. Great. Well, that's probably okay, isn't it? There you go. Can we do that? We can do that. Brilliant. So, we've done that. I think it might be time to fix up the schematic sheets, but I can do that later. Certainly assign reference designators, which is something I've never done in KiCad. They're going to be do stuff, annotate. Yeah, where would that be though? In tools? Annotate schematic. This entire schematic. Let's go for Y first. Yeah. First free number after 0. Oh, after 0, so 1. Go. Done. J4. 1. Yeah, looks good. Are we all happy with that? Have a look at this sheet. Oh, it's on the toolbar as well, is it? Look at that. I can even guess by the icon. Yep. Cool. I think I'm happy with that. Now we've got to go back here and click on the KiCad. So I think that's the project, isn't it? This one. Oh no, the .pro is the project. That's actually a PCB, isn't it? There we go. That's the PCB. Now we need to bring things in. Oh, that's a very good point. So this is a change in my flow thing again. The button that looks like a schematic pointed. The button that looks like the schematic pointed to the PCB. This one. Symbol editor. Oh, on the PCB editor top toolbar. Schematic pointed at update PCB from schematic. Ah, but don't we need to do footprints, or is that going to do it as part of this? Uh-oh. Can't. That's very important, cool. Okay, let's cancel that. Footprints first. I think from my previous playing, there were some kind of... No, maybe not. Okay, where do I do footprints? In the schematic editor. Footprint, I have to pick. I see. 2 for low and 7 for high. Let's just check that quickly. Oh. Kind of wondering about some kind of rat nest thing that we can do to support different pinouts. Maybe I'm overthinking it there. Table icon, this one. Symbols. Yeah, neat. Okay, so capacitors, 100 nano should be fine on 0402. That's not going to be just typing in there, is it? Capacitor. Capacitor SMD 0402. Now, metric versus not metric. Oh. Oh, what's a metric again? So that's if I choose 0402, will I get an 0402 or will I get a 1005? Okay. Let's go with that then. And that's got round rects on. The difference here being hand solder, so it's slightly wider, is it? Go on then. 4.7 micro. It's not good for hand soldering. Oh, sorry. So we got the hand solder and we got the one without hand solder. Cool. What can we get? I know, 4.7 micro. Oh. I'll just go for a standard footprint then. Let's just go for standard. 4.7 micro. Sorry, I'm not showing you. Yeah, ceramic. And we want sort of 16 up. Don't really care about the others. What sizes can we get? Package. We can get 402. 3 parts. Let's go for a 603 then. That should be fine. Oh, 603. Like that. Uh, 120 ohm resistor. Knock off the easy ones first, I think. There's a bunch of these. 120 ohm. What is this? Nope. 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 120 ohms. 120. Not micro, not milli. There we go. I think this is probably going to be a 402, isn't it? Yes. It'll be fine. Oh, actually, hang on. We were passing, what was it? 200-ish milliamps through it? Okay. This is in the termination. 200 milliamps, yeah, so that's going to be... Give me the text field again. 200 milliamps. R is 120 ohms. And then P is 200 milliamps times 120 is 24 watts. Well, we're not going to be achieving that for very long. Oh, no, sorry, I've done this completely wrong. Yeah, quite right. We're not going to be doing 4.8 watts for very long either, though. PIVVIVVIR. So say 24 volts over 120 ohms is 200 milliamps, just as you say. Is 0.2 times 24, right, 4.8, thank you. Sorry, my brain is probably getting tired by now. I think 0805, let's have a look, see. Never remember what they're rated for. You go for 1206 or bigger. Oh, Rink's getting a lot of use tonight. Feels like something you quite enjoy. Yeah, so these are still 0.3 watts. So they're going to get toasty if we do get a failure mode. But I think that's probably okay. This is a 1206. Let's go for 1206 then. This one. Capacitor, resistor, SMD, 1206. Ah, nice. Save. 510, that's definitely... Actually, what was the 510 ohm resistor? I can't remember now. I might just wander around the schematic instead of... Oh, that's the 510. Yeah, so that could be 0402, no problem. 0402. We've got these, it can be 0402, fine. 0402. This is where I should have done the table. Copy. I just copy and paste the name in there, so happy. This is a 1K, that is the only 1K resistor. I'm tempted to give it the 25K as well. 25K. Like that. 0402. Yep. Cool. So what are we still missing? Oops, wrong button. No, close. Q2, Q4, which is going to be that one down there for the LED. Okay, sounds good. Is this a library that I just have? R Haze? No. Will I need to clone it and add it to my installation? Oh, did I? Oh, is this in your library? Yeah. So from here, I think it was footprint libraries. I think I added you. Maybe not. Oh, there we go. Do I need to do them individually, maybe? Gotcha. I can do that. Can I just give it a folder? Oops. Will that just happen? Oh, sorry, I can push this button here, can't I? There we go. I found that earlier. I can do multiples, look at that. Boom! Save. Okay. So if we then come back into here and we edit this one and we go for RHJIS, package SMD. What did we actually go for on that one? Do you remember? We picked it apart and I think we just discarded it, didn't we? Unless it's still open here. There we go. Let's put that quickly into our property here. NX702BKW. MFR is an Xperia. Okay, so this is actually an SC70, which is SOT 232. SC70 SOT 363. SC76, that's not what we're after. But we are after something similar, so I think we need to tweak it. Unless there's already another one. That's okay. SOT C73, okay. I'm I'm going to be lazy. I'll come back to this and tweak it up in my own time instead of on stream, I think, if that's okay. I will put a note in there, though. To do, make this round rect, no footprint. It's not hand solderable, okay. I'll come back and tidy this up. I think we're probably not going to get to layout today, unfortunately. Looking at the time, which is a shame. I'd hoped we would. So that TVS diode hasn't got a part number either, which is annoying. What did we go for in the end? It's an LED. Oops. That's another LED, same LED. Okay. We're after a TVS diode. No. Oh, was it LCSC? Yes. This one. Well remembered, thank you. And that is a slot 23, which I think we might have one of in package SMD. Slot 23 looks good. Nice. Okay, missing the opto, missing the DE9. We've got these headers. I think we might have something. Nope. Connector. So we could go through whole be lazy, or we could go for surface mount and be a bit prettier. I'm not too bothered either way. For production, if we get there, it might make sense to have surface mount. So 2x10. 2x10. Nope. Nope. Yes. What does that fit? Is it generic enough that we can just go for it, do you think? Pin socket, I think, is probably exactly what we're after. Can we view the 3D model with this? Is there a 3D model? There we go. Yeah, that's what we want. Nice. Fairly generic. I think that looks fine though. That's exactly the kind of thing I was looking for. So let's just go for that. Vertical SMD. In terms of J4, that's our magical thing. Right, okay. So let's then work on this one. Oh, they're not too bad to hand solder. Yeah. We've got MFR and MPN. How are we doing in terms of people? We still got a few people. Hello, everybody. Didn't check after the internet went out, so it's good to see you here. I think it was a Toshiba part, wasn't it? Toshiba. DLP240A, here we go. So in here we're going to have a footprint probably somewhere at the back. We're going to go for the surface mount one. Great. Okay, what are we after? We're after a surface mount option. Big feet. Go for this one over here. LF5, TP5. Not sure I'm fully understanding what the difference is there. Oh, lead forming option, taping option. Okay, let's have a quick look. Let's put that in there. Keeper. Footprint. We can go for... Is there a search? Select footprint to browse. No. What are we going to be doing then? Opto device. Toshiba. No. It might be somewhat generic, but I think it's probably not going to fit a dip, is it? No. No, it's not going to be one of them. Oh, look, terminal block. Oh, that's not going to be what we're after, is it? Through-hole leads with stamping on the end and crimping or cutting or whatever, yeah. Probably true, yeah, in terms of the not strictly opto isolators, but solid state relays, I think, is what it's aimed at or marketed as. Isolation voltage 5000 RMS minimum, which is probably okay. I think let's make a footprint. Lucky enough that we haven't done one yet, so let's go for it. So that's got all the stuff in there. Okay, not that, no. Footprint editor, bing. Okay, have a look at this. New library, I'm guessing, just for us. Glasgow can.pretty. I presume the .pretty is is a, I don't know what I would call that, a vanity extension or something like that. Yeah, let's do it. New footprint, print name, TLP240A, and then we're going for taping option, TP1, TP4, TP5. Oh, I see, that's the packaging more than anything else. So I'm thinking TP5 over here. So what are we actually ordering here? We are ordering this left column, I think. And I'm after a TP5. But that's not in this list. Oh, example item name. So it's TLP 240A bracket, TP5, comma, F bracket O? Is that what we're going with? That seems bizarre. TP5, F bracket O. Or 0, that's an O, I think. Which is this one. Does that actually exist if we just search for it? Sort of. Okay. So we can just underscore 5, which will pick this one. Alright, let's go with that. Underscore 5. Ooh, okay. Again, I'm going to put this on my other screen, but... Oh. TP4, TP5, okay, that's fine. Not such a bad footprint. It does look odd when compared to those diagrams or images to below. But that's fine, whatever. Okay. So we need a pad. Oop. What can I do with these pads? Pad number 1 is surface mount. It's round rect. Woo! Look at me go! I'm going to put this on 0. I'm going to make it 1.6 by 1.6. Orientation. Like oversize them a bit. Before you plug a pad, the pad with cog configures what button gives you. Pad with cog, oh, up here, okay. Oh, so I can like set a default? Cool. Yeah. Okay. So if I'm going to oversize this a bit, I want them to be a bit taller, so that's in the Y, so 0.7, 1.8, let's say 2 millimeters, shall we? It's a bit high, you want it reducing, okay, let's give that a go. Click, oh look at that, nice. Corner radius is here, corner radius, 0.25 millimeters, right, okay. Right, 1, 2, 3, 4. How does the grid work in terms of like pick and place things? So do I need to put the center of my part on this cross, or can I put an origin somewhere else later? That's very true. It's 2.54. So actually, 1.27 is half that, isn't it? So what I could do is really lazily go and put this like that and this like that, and they should be then. Control M? No. Shift M? No. How do you measure? Measure. Control Shift M. There you go. 2.54, which is good. And then I can put the same down here. And they need to be 8.7 millimeters apart, so 8.7 divided by 2 is 4.35. So that's actually that and that. Can't do them both at once, okay. Position X, position Y, minus 4.35. And actually that's not right because I didn't include my oversized. I oversized it by 0.4, so that wants to go up by 0.2. Does that look about right? It looks very long and thin. Let's see if we can find a picture of the package or a diagram of the dimensions of the package. There we go. 5. Right, so looks good. I got my pin numbers wrong, so we can fix them up and put a drawing in for the package. So this is going to be 1, 2, oops, 3, 4, and now I can do a box. I want to do one of them probably, and I want to draw it on. What layer am I drawing on? Oh, here we go. Front silk. Yeah, that's okay. Front silk, sort of like that. This wants to be XY. That's 6.4 millimeters, so 6.4 divided by 2 is 3.2. 3.2, 3.2. Boop. Then again here. And then this is going to be 3.2 minus 3.2. Give it minus 3.2, 3.2. Looks okay. Pin 1 needs a spot on it because, oh, for goodness sake. Radius millimeters. A bit big still. I'll make the line thicker. Yes. 0.5. I'll do. How's that? Probably all sorts of other things like courtyards and stuff, but I'm gonna maybe. Oh no, let's do it. How do I pick this layer? I'll just click on it. Okay. What's this then? Graphic polygon. Just draw. Turn that down. Like that, I'll do. 0.25 millimeter courtyard. Very well. So this is. That's actually wrong. The package is in fact 4.58 millimeters wide, which makes that 2.29 minus 2.29. Is the courtyard something which can happen automatically, or do I need to do that by hand? Oh, what? I'll do that by that, and it's that by that. Okay. Oh, it does snap at least, that's okay. So, you want 0.25 millimeters on top of that, plus 0.25, 2.54. Oh, well, that's a nice number, isn't it? This is then at 5.44 and it's 2 millimeters, so that's 1 millimeter, so that's 5.55 plus 0.25 is going to be 5.8 That's where this needs to go. 5.8. 5.8. Minus 5.8. Hit it, please. Come on, thank you. 5.8 minus 5.8. How do we feel about that then? You want a bar on pin 1? Oh. I'm going to leave my spot. Front silk, bring that back. Okay, I think that'll do. So now we can come back to here and give it a footprint. Be in the Glasgow library. Glasgow, oh, look at that. Done. Whoop. Oh, all right. Let's fix up the spot. What did you want? 0.3 with a 0.2 mil thickness. Nice and small, that's good. Oh, I can. Okay. Is it allowed to be outside the courtyard? It is currently huge, you're quite right. Ah. Like that? Happy? So now we're missing the DE9, the plungers, and the LED. Yeah, I was wondering about you. You wondering about that? Therefore, I'll do. Cool. So the LED needs a footprint, and the LED comes from... I can't remember what the name was now. It's probably still open somewhere. Here it is. Nation Star. And it's got a land pattern like that. That's a 2.5 by 1.8. Are we going to try and use another existing footprint, do you think? Or should I just draw? I'll just draw one. Which was the library Esden mentioned earlier? I know it was Esden that recommended this LED. Excuse me. More water. PKL library. Pretty KiCad libs. Okay. Is that something I should search for? Go for it. Oh, it's your own library. You come up first. Oh, it's massive too. Thank you very much. Glasgow can. That's fine. Oh, so these directories are pretty. Were they always directories as pretty? I don't remember now. footprint libraries. Project specific. No, let's do global. I can fix this later because that's most likely wrong. And so I'm going to do all of these pretties, is that right? Oh, I see. I had thought the file extension was pretty. I didn't realize they were directories. PKL, look at that. Okay, so it'll be LED. And it's a, what, 2.1 by 2.1? Or is it going to be a 2.5 by 1.8? Who's faster at giving me answers? So LED tried 2020. LED tried 2020. Okay, sure, let's go with it. I'm going to trust you. PKL, LED, try 2020. And this has got 1 is red, 4 is green, 2 is blue, 3 is plus, yeah. Hello, Will. Are you by any chance Will C in the in Discord? And if you are, went for the TCAN just because I've used it before. Let's have a quick look at this MCP one. Welcome. Good to have you along. So we were discussing the one wire thing earlier, and I was wondering about just leaving it off for the moment, but allowing to. So we've got two interfaces. We've got one DE9, which the plan is that will go to a OBD2 cable, and then we've got another one which is based on. What's it based on? Let me just dig it out quickly. This one here. So it's a nice sort of finger accessible design, or connector, or whatever you want to call it. So if you want to ground the low CAN-L, then you can just hook it up. We can certainly add a jumper, nothing against, just if that's all you were after, we can put a jumper in there for sure. Between CAN-L and ground. Yeah, so this deals with FIFOs and all sorts. This is an SPI part by the looks of it, and what we're actually going to be doing with Glasgow is implementing all of the logic in the gateware on the Glasgow. So we just want a transceiver. We don't want sort of a full SPI CAN controller, whatever you want to call it. So I hope it's okay that we didn't go with that one with you. In terms of a CAN-L to 0 volt jumper, then absolutely, let's just do that. So it'll be a 1x02 pins, I guess. No worries about that I am new. No worries at all. It's very different mindset when you're working with Glasgow, because you don't have to put anything into the hardware. You actually want to sort of draw as much of it as you can out into the gateway, so that you have control over what's going on as much as possible. So let's just do a pin header like that, I think. Horizontal, vertical. I'm going to go vertical. Looks good to me. Is that what you're after, Will? Yeah, the jumper. Nice. Let's leave it at that then. So now we're looking at the D9 and that 3-pin connector, and then we're good. Perfect. I'm pleased to hear it. It doesn't look pretty, but maybe I'll tidy that up later. I would be very surprised if there wasn't a footprint for one of these in there. This is going to be a through-hole part. It's going to be generic D sub, 9, horizontal. What are all the options here? Offset. Oh wow. That's a bit precious, isn't it? Let's find something, shall we? Forgotten what we chose in the end. It was male pins. Plug and receptacle with male pins in both. I have to just filter that out in a minute. So I think what we're after is one of them. And that is supposedly a female. This is so stupid. I really, really hate it. Right. Through hole, right angle, correct. Let's filter that. Plug male. Flange feature. Oh, I see. So I'm looking in the wrong column. Let's just go for it. 59p for one of them. And the drawing says that the pins are 2.84 millimeters apart. 2.84 millimeters. Oh, I see, okay. Now we've got the other thing. I think that's probably a fair way of doing it. It makes no sense for things which have got shrouds, for example, like just like the D9, right? So you've got pins, but you've also got like the body of the connector goes into the other one, and it's stupid. But anyway. Where were we? We were not there. We were not there. Here. So we've got 8.1 from the first pin to the edge. 8.1. What are we measuring between? 8.2. That looks big. I hate this. This is the kind of thing where I just back down and draw my own at some point as well. Tell you what, let's get the footprint editor. Let's look at the... Oh, what's happened here? We've got another window open, is that why it's unhappy? Ooh. Footprint editor, is this gonna work now? Yes. Connector, D sub. make it wider. No. Yes, maybe. Okay, so if we measure between... Oh, okay. Oh, can we snap to things? Yes, we can. We can only snap to corners, okay. Snap to there. Can we snap to the center of that pin? No. We can snap to pin 1. Oh, I remember this. We can't snap. Can snap. Edge pin offset 9.4. So we're looking at the Y value here. I think this one is not what we want, because that's not got the extra fixing holes. We want these extra pegs either side to give it the rigidity. Top one of the set. Okay, let's have a look. Oh, this one? Well, the highlighting's gone a bit wonky here. Yeah, so we want the housed mounting holes option, of which there are 5. I don't think it's that, because that's really long. I don't think it's that, and I don't think it's that. So it's probably one of these. So this one gives us a 7.48 millimeters from somewhere to somewhere, unknown. So if we measure from that corner to pin 1, we get a Y of 8.18. That's the wrong thing. If we look at here, we've got a value of, oh no, 8.1, there you go, from the other pin to the front. The 9.2 gives us what? Can't lock onto that. That's 10, so this is, yeah, this is more likely, I think. Oh, come on. Why is it you can only snap to pin 1? That's ridiculous. So that is 10.94. Let's note this down. Minus 10.94 millimeters. And then from that pin, so this pin is going to be 2.84. 2.84 is going to be 10.94 minus 2.84, 8.1. Right. That feels good. This says 8.1, that says 8.1. Let's go with it. So it's this one, the 9.12 offset that we want, I believe. What did I say? I can't even remember now. 9.12. 9.12, 9.12. 9.12. Done. Snap. Just pretend it's a thing all done now. Meanwhile, let's take reference to this so that we've got it. IFR. Nope. Can you? Yeah. Oh. This one? No, this one. And I think I'm going to put that into here, like Rachel suggested as well. With both, by any chance, Will? Okay, so the last thing I think now to do is that connector, which is exciting. This is the nice finger-friendly one I was talking about earlier. This one, which is a T connectivity. What is it? 283, this one. Now, I would be surprised if this has got a footprint in a way, but we can certainly look. What are we going to go for? Why are we using pins 3 and 5? Well, that is a very good question. We must have spent about half an hour umming and ahhing about what pins to use. We've settled on the pins 3 and 5 because the OBD2 cables to DE9 tend to seem to expose them there. So if you have strong opinions otherwise, or sources or whatever, then please let us know, and we can override it, no problem. That's fine. Rachel had a pin out, and then Rachel referenced us to the I can't remember who make it now, canned adapter, which has another pin out, and so most of your tools use 2 and 7. 2 and 7, yeah, okay. I think that lines up with one of the products we were looking at, Peak Can, that's the one, yeah. So, to be honest, I'm slightly wondering about whether we put a pair of pin headers that we can then just allow people to jump across. Omni Technomancer, are you saying that Peak can use a different one to NI? Because that wouldn't surprise me at all. The thinking being really, Will, here is that we've got this other connector, this sprung-loaded terminal block, which means that if you have something that's not compatible with that, then we can just feed it in, plug it in, and you're done. I agree, Rachel. It's optimal, but it's not friendly. That makes sense. You can't just plug it in, but at the same time, you can plug it in to things which I haven't designed for here. I'll let the discussion continue for a bit while I try and find a footprint for this part. Nope. No, mate and locker them, aren't they? Of course. Forgot about that. Okay, I'm going to say there's no pin out or footprint for this, so let's make one. Just catching up on the chat. I think I'm leaning towards, it sounds like you're leaning towards using a pair of jumpers for this. And I think that clear silk is going to be required as well, so let's just do that, shall we? So we're looking at jumpers which will allow, so I was going to go for full flexibility, and I was going to say that, let's just move these out of the way slightly. So we have 3 here, which gives us 0 volts, can low, can high, and then we can go across the gap to 8 or 9 pins, which gives us the ability to plug into any of here. I'm not sure 1x9 is going to be particularly common though. It's horrible. I really hate the way we've ended up in this situation. So kind of like this is what I'm thinking. Feel free to vote on yay, nay, whatever. No sorries, Will, unless you're apologising for something else. This is good discussion, and it's a tool, so it needs to be flexible, usable, etc. Definitely don't say sorry for that. It's quite amusing in a way. The industry as a whole has not settled on anything, but they've all used the same connector. Long wires on CAN, don't forget it's a maximum if we're using CAN FD of 5 megabit or less probably, so I'm not sure that we'll have much of a problem with that. You can always twist them and make them shorter if you want. Could we arrange this such that handbags could do sort of a common pin combination maybe, or something like that? Or is it going to be best to just leave it flexible? Yeah. Let's go with that then. So I will get rid of all of this. That's... Yeah, there we go. Oop. Oops. Feel free to shout if you think this is a really bad idea, but I think it's a tool. It's got to be flexible, and if we're tying ourselves into one particular cable, which is possibly not even the one that most people use, then that's a bad idea. I agree, Esden. Yeah, we get much better stuff from collaboration and working together, or whatever you want to call it. I think the silk on this is going to be really important. I might even draw sort of a dotted line or something between. I'm not even sure if I can pick one standard to go with for the dotted line actually, so maybe I'll just back off on that. Certainly number these pins and certainly label these pins, but yeah, let's leave that for now. What was I doing? I was doing a footprint for... Add new footprint, please. Can I have a new footprint? Thank you. Footprint for this, which is a TE 3 position 3, so it's a 283477-2. Very fun indeed, yeah. Right, this part has, we're going for the 3-pin option, and it actually has 2 pins per slot hole, whatever you want to call them, for rigidity, I guess, because you're going to be putting quite a bit of force down on this lever to open up that entryway. So I'm going to label them as 1, 2, 3, 4, 5, 6, 7, 8, 9, or even 1 through 6. Don't forget your labels. I'm going to label them, or pin number them 1, 2, 3 through 6. I think, unless KiCad is okay with 2 pins numbered 1, I think I'd probably try and avoid that. And yeah, let's go for it. There's another one in here, isn't there? Footprint. Aww. No, it's not there, never mind. So we're doing through hole, we're doing a circle. Add to die length. Oh, plated through hole, no, yeah. Right. Hole shape circle, okay, right, so. We've got some drills, diameter of 1.3 millimeters, and therefore I'm going to make the ring quite a bit bigger than that, maybe even 2 millimeters. I think that the part we've chosen can do 5 megabit, okay, and you can probably push it past that. this is on a 5.08mm grid on one axis and then a 5mm grid on the other axis, which is lovely, of course. I think that's all okay. Give me some pads. Let's go for... Oh, I can't go bigger. Enter user grid. Oh, can I do XY? Oh, I can do XY. So I can do 5.08 there and 5 there. That didn't look like it did anything, but let's see what happens. What have we got then? Those are like huge holes, don't they? Oh, well, what have you caught? We've gone for the TCAN 1051 HG, which has got the high voltage whatchamacallit, here you go. High voltage bus protection, as well as the 5 megabit flexible data rate. So I think we are probably covered for that, hopefully. Yeah, nice, cool. Right, so this pin here is 00. This pin is, yeah, 2.54 because I didn't pick my user grid, I see. Let's try that again. That's why I didn't change anything. Much better. And now I've got billions of numbers wrong. So that's 0, that's 5, which is correct. That's then 508, yeah, good. Yeah, cool, okay. I'm going to make these pads. I can't do them all at once. Brilliant. Can I do a table view? Edit lots of things at once? No. Footprint properties? No. That's kind of annoying. I'm going to have to delete them and start again. Okay, click on this. Make that 2.5, do you reckon? Yeah, that looks better. Pad number 1. I'm probably going to get shouted at in the comments by people telling me about the rules that I'm not following. So I'm going for just like the image here, on the right hand side of the screen, we're going to be going for pin 1 through 3 on the right hand side. The left is 1, right is 3, which means that the front or the bottom row are going to be 1, 2, 3, and the next row I'm going to label as 4, 5, 6, I think. Does that make sense? Or should I do? Yeah, I think so. Let's just go for it. Because the front row are the ones that you're really looking at, aren't they? There we go. Right, okay. Go back to the standard grid. Automotive Ethernet, as in a single pair for 100 meg, I think it is pretty cool actually. I've not used it at all, but vaguely aware of it. Okay, now the next thing we've got is the width is A plus 0.5, A being one of these dimensions here, so we've got A plus or minus 0.5, sorry, so it's actually just full A, so it's 16.24. So if we go for 16.24, what is that? Can you let me edit the line, please? Okay. 16.24. Move the line, please, thank you. Okay, so the offset between the pin center and the edge, the right hand edge, I want the left hand edge really. I have the left hand edge, I don't. But I can calculate it based on what? So 16, this is where a notebook becomes handy. we've got, so this dimension A up here comes from the bottom right hand corner where it's at 16.024, free position. So the full width is 16.24 plus minus half millimeter. Then from the center of the pin to the right hand edge, because they are actually not the same, these are stackable. So if you want a 4-pin or 4-hole version, they just smush 4 of them together and then put an end cap on. So that end cap is actually a different thickness, I would imagine, to the end cap free side. So we can get that by going 2.98. So that's 2.98 from a pin to an edge. .98 millimeters. And then between the pins is 508. 5.08. We got another one of them, 5.08. And then that last difference there is going to be what's left. So if we grab 16.24 minus 2.98 minus 5.08 minus 5.08 is going to be 3.1. So from this pin here to this edge is 3.1 millimeters. And that's what we want on this footprint. So start point X is minus 3.1. And then the total width is 16.24. It would be nice if you could type things in here. 6.24 minus 3.1 is 13.14. 13.14. And then if we measure, can we measure that to that? We get 16.24. Lovely. Do another line from there down. Oh, great. Yeah, that's nice. There we go. Okay. Now we need the next dimension, which is going to be front to back. Do we have a front to back dimension? Yes, that's here, 14.3 millimeters. So we're going from y minus 2.54. That's actually quite probably wrong, and we need to fix that quickly. Diamond files do magic. Here we go. From the pin to the back of the unit is 5 millimeters. So this needs to be on -5. XY says -5. There. Means this needs to be -5. And that means this needs to be -5. Give, thank you. XY, yeah, -5, there we go. And then, again, we haven't got the dimension to do, but so we need to calculate from the front nose to that pin, which is going to be 14.3 minus 5 minus 5 is 4.3. What we actually wanted, sorry, is 14.3 minus 5 is 9.3. So here, we want 9.3. I think that's looking good. 9.3. And then just draw a line between the two. Ta-da! Because of what these are and you know the fact that it's quite important, I'm actually going to draw a little paddle up here, I think, in the silk. Is that a paddle or is that not a paddle? Can I change my grid on the fly? I can. Does that look like a paddle, everyone? Or is that an entry? Like reference point for the copy of the pin. Like reference point for the paste. Nice, cool. And then I think I'm going to draw a little hole here instead of a paddle. And that's just going to look like that because I'm lazy. You'll not read into that. It helps with orientation a little bit, right? It's not very pretty, but I think it kind of gets the point across, maybe. Nope, can't grab that. Can I move them? Oh, M still works in here. Yeah, there you go. That's just me, isn't it? Definitely just me, for the reference there. Oh, is this the ref des? As in the thing on the silk? In that case, I'm going to put it on the side. Oh, fair enough. I'm also probably going to move this into the middle, like that. I'm not sure if it really matters. I don't remember what we did for the other one. Yeah, we did move it. Yeah. Cool. I think that works. Let's come back in here. What are we going for? This part here is one of these. Glasgow. Ta-da. Let's give it an FG of T connectivity. I'm going to copy it. And then the part number, there we go. Cool. I think that might be everything. Oh, no, it's not. We need to put these two in. We also need to do the ref des for them, don't we? Annotate, replace all existing, go, clear and annotate. Yay! Right. I think we've got a couple of these already. We haven't done anything about labeling them in terms of getting a part number for them. Center, center. Works. Center, center, that works too. Oops. Center, center. It's strange, isn't it? Oh, interesting about rotation. That's good to know, thank you. Cool. I can get rid of that note now as well, can't I? Like that. We just want standard pin headers for these. I want to block no. What are we going for? Connector, pin header 2.54, and it's what? 1.9. There is a 1.9. Vertical. Go. 1/3. Pin header 1/3. I do kind of wonder if these should maybe one day be maybe surface mount something instead, but that's good for now. I think that's awesome. I'm going to do a rough place and then I'm probably going to call it on the stream. So I hope that's okay with everybody. Let's just do a rough place, important place. So we did this earlier, we tried to do it earlier at least. There was a button, tools, no. Oh, I don't know where it is. This one, found it. Errors. Oh, FPR not found for U1 and U2. Let's go back, check that. FPR, oh no! What is TCAN thingy? It is a, there's gotta be a footprint for this, I think. Oh, what did we go for? Oh no. We went for DFN8, I think we did, didn't we? The HG one. There's a 3x3 if the VSON is what you're referring to as DFN8. Oh, here we go. Okay, none of these tell us about ordering and part numbers. There we go. Oh, okay, we didn't pick. Yep. So, what we want is the TCAN, let me search for this because then I should highlight it, TCAN 1051HGQ1, which is here. And we'd quite like the VSON 8. Okay. I'm guessing this is the packaging size, not the part size. 35 millimeters high is a little bit tall, I think, for a DFN. Okay. Right, so we want the HG. Oh, I hate these part numbers like this. DRBT. Yeah, that sounds good. HG DRBT R. So it's tape versus reel, don't really care. Let's just take that. Oh no, it's definitely 35 millimeters on the right hand column, look here. And a length of 340 millimeters. What does F8 do? Am I missing out? Oh, nice, okay. Shortcuts are always good. Get rid of some calculators, get rid of some notepads too. Right, so TCAN 1051 gives us a series of parts. And let's just do it this way because it's going to be easier, isn't it? Five meg bit. Okay, I said it was going to be easier, but it's still not. Excuse me. The measurement, yeah, I think is the packaging size, not the part size. I'm going to go for this one here. This gives us half duplex fine 5 megabit, VSON 8, there we go, DRB, GV, oh no, that's the HG, we want the G. None. Boom. Not existing. Okay, I will go for a, as you say, footprint 3x3 DFN. Am I going for a pretty one? Am I missing it? It might be end of stream time, to be honest. PKL. Oops. Oh no. You might not have it, okay. Let's go for DFN. 8 pin 3x3. 8 pin 3x3. What are we going for inside it then? Pitch. Pitch is 0.65. This one. And then we get rounded or not rounded, I think. So rounded, not rounded. Okay, let's go with rounded. Ooh. Oh, exposed pad. Have we got to do something with that? We didn't give it a pin. Not actually listed on here. I guess we can just leave it floating then. Other master, nope, not that. Oh, what did that say? Go back. Build the print cycle for thermal and mechanical performance. Doesn't give us a net though. I'm going to leave it unconnected. Pin 1 ID optional, it's not that. Probably, yeah. The kind of thing you don't want to connect and then find that it's not, or it's not happy, or whatever. I'm going to leave it floating. I don't know how they deal with it in the library. Wait. What have we got? Is that the library editor? Yeah. Yeah, sorry. I decided I'd try and make a go of KiteCAD. I've not used it before. Because this is Glasgow, open source, everything, I figured I'd give it a go. So apologies if it's slow and painful to watch, but hopefully it's not too bad. Right, we found our DFN, didn't we? We found it. This. Away. Nope. Like that, I think. There we go. So this is pin 9, okay. I think that's alright, isn't it? We can just leave it floating. Cool. And that means we're done. Oh, that's kind. Yeah, everyone's got their own opinions and ideas, haven't they? So you're coming from one to the other. Look! Ooh, it's exciting. Get off. Oh, okay. Right, so we've got a connector, which I'm going to put over there. We've got one of these and one of these. I'm going to place approximately in the right place. So J5 is port B. And if we look at the Glasgow, port B is the lower one. Oh, there's a massive lag on that now. Those frames have stacked up, haven't they? So port B is the lower one. I'll put port B there. This is then J1, which is port A. That's fine. Pin 1 should be over there, which is unfortunate because it's not. Oh, sorry, I missed something in chat. Check the size of the pad in the footprint. That is 0.7 by 205, which is a little bit bigger than that in both dimensions. That's a very good point. Thank you, Rachel. I was getting a little bit panicky there. So can I just push it to the bottom? Do I need to? Oh, board side, front, back. There we go. Lovely. Same again here. Front, back. That's probably a quicker way of doing it. So yeah, pin 1 is on the internal right-hand edge. Pin 1 is on the internal left-hand edge. We've got that connector, which I'm kind of expecting will fit between the two, maybe just about. Then we've got all the CAN related stuff. This needs to go sort of there-ish, which I think is okay. Oh, have I got my nets wrong? CAN 2, CAN 1. That's okay. So J4, where's J4 come from? That is J4. It's just in amongst everything else, even though... Oh, okay, all around this looked like it was related. Put that there. This one then, I'm thinking will go over here. And then some can sort of stuff will happen there. Look at that. F to flip, cool, thank you. Look at that. I think that'll do for today. If I can, I'll hold off and continue it next week, I think. That's really nice to have got that done. Yeah, so I might tidy some stuff up in the meantime, but I'll try and save the layout for next week if everyone's interested in seeing that. Need to do the board outline and put things in their real places, which we'll leave for next week as well. There are a couple of to-dos I think we left in the schematic, but yeah, I think I'll do for today. Yeah, so the exposed pad in the footprint is actually slightly larger than the datasheet calls for, but it's 0.1 millimeter. I think it'll be okay. But yeah, let's leave that. I'll put in maybe a to-do note in there, say just to verify that. To-do verify footprint. There we go. Put that there. Cool. All right. Thank you, everybody. It was good fun. Sorry if it was painful watching me trying to use KiCad for the first time. I hope we've made good progress. I will be pushing this to GitHub. I can share a link in the Glasgow channel for anyone to review it if they want to see. And yeah, I think that's it for today. So thank you very much, and see you later. Bye bye.